All right, I guess you're about ready to go, right, Rich?
I'm ready whenever you are.
All right, we'll get started. First off, let me welcome everyone to the Long Building Environments Coffee Break. This is, of course, a weekly series that we do on various subjects, and we'll keep this brief and would ask that if you do have any questions, to type them in as you go along. We'll handle those towards the end. We'll also open up the phones after the question and answer period if you want to stay a little bit longer than the 15 minutes allowed and talk about anything particular for you. So just to let everyone know, we are on a recorded line. Again, if you would hold your questions until the end, just type them into chat. We'll keep everyone on mute at this point. So joining us today for this conversation on water source heat pumps is Dean Grunsteth. He is the Western Regional Sales Manager for Water Furnace, and also Rich Congling. He is the Director for Commercial Applications Engineering at Water Furnace. He'll be doing a lot of the heavy lifting and the talking on the subject today, but I think this is very appropriate for not only expanding what we can do with water source heat pumps, because we don't see a lot of zoning, and that's primarily what we'll be talking about today with water source heat pumps. But also we see a great surge in the technology now when we're talking about net zero buildings. Being able to share that heat around the building has a huge influence on that, as well as heat recovery chillers and heat recovery applications that we see with water to water devices with Water Furnace. So Rich, appreciate your time today, and whenever you're ready to start.
All right. Well, thank you, and thank everybody for taking the time this morning to join us on this subject. Water Furnace is focused on our future, and we're grounded by our passion in the past, which has been water source heat pumps, geothermal heat pumps, and the culmination of all of that is really the Versatech variable speed product. Those are modules that are available in sizes from 2 tons to 15 tons. And through factory configurations, we're able to handle a number of different of applications and different things. The one that's not shown up here on the screen today is one that was just recently released a few weeks ago, and that's a dedicated outdoor air system. So with the factory configurations, we can alter the unit to be applicable to single zone VAV, multi-zone VAV, zoning, and dedicated outdoor air systems. And today we're going to be talking about the zoning system, the IntelliZone 2 zoning system. The IntelliZone 2 zoning system has the capability of handling up to 6 independent zones of control. Because of the virtue of its variable speed, direct drive ECM blower motors, we eliminate the need to introduce bypass dampers to reduce airflow coming back from the space when zone dampers are closing off. The zone dampers themselves do have minimum adjustment positions to maintain minimum airflows in each of the zones at all times. And really, IntelliZone really changes the game in terms of thinking about a water source heat pump. At the heart of the control is the IntelliZone 2 board. It is field installed near the unit. One of the primary functions of that is to provide relay control for the individual zone dampers. It also provides us the ability to pull back information from each of the zones in terms of temperature, humidity, and other data from each of those zones. Secondly, the zone dampers themselves, you'll see them outlined here on the items numbered 2. They're available in either round dampers, 6 to 16 inches, and rectangular dampers. The construction of the dampers themselves are a heavy gauge galvanized steel, low leakage dampers themselves with seals. They'll withstand up to 1 inches of external static pressure, and the actuators are a Belima 3-wire powered open and close. The reason that we use a 3-wire actuator is to eliminate the need for the spring return, which typically is a common point of failure when you have actuators that are actuated for long periods of time and present that resistance against that spring. It becomes one of the weak links. It also allows us to have low amp draw for the actuators and allows us to put multiple zone dampers onto a single zone, or we could use just a single damper for a single zone. So again, different flexibility there for different applications of duct design. The last component is the field installed zone sensors. There is a primary zone that is identified, and it receives in a standalone operation a master thermostat. That master thermostat can see all of the additional zone sensor temperatures and set points that may be implied there, and then each other individual zone would have its own zone thermostat or zone sensor applied. So we're again getting all of that information about each individual zone and taking that back to the IntelliZone controller. The IntelliZone controller then makes the complex decisions based upon the size of the zone or the weight of the zone, as well as the priorities that you present to the controller as to which zone has the priority. And in most cases, that's the president CEO's office, but within an organization, it may vary from application to application. That controller then talks to the advanced Aurora controls within the Versatech variable speed in order to make decisions about airflow requirements, mode of operation, things of that nature. So it acts as a completely integrated and functional system in the unit. Here you should be seeing a typical school layout, and this is not an eye test, and I apologize, but each one of the red rectangles actually represents a water source heat pump, and this is a school construction plan. So you see a number of water source heat pumps, and we're going to be focusing in on the area identified in the blue dotted line segment. This particular area happens to be a broadcast studio and classroom. You'll notice on the drawing on the left there are three water source heat pumps located in the corridor, circled in yellow, and then one right in the middle in the office, located probably above the desk or the filing cabinet, the two most heaviest pieces of equipment in the room. There are 4 water source heat pumps that total 8.25 nominal tons, but there's actually only 7.5 tons of actual capacity required that the engineer scheduled for these spaces. As I mentioned, these 4 units provide us with only 4 zones of comfort control, and it requires 14 pounds of R410A. And I started putting pounds of refrigerant onto some of these presentations because as we start moving into A2L refrigerants in the future, that's going to be something we're going to be obligated to manage and minimize. And then per the equipment plans and specifications, our bid would be right under $10,000. An alternative to this would put 2 water source heat pumps, variable speed Versatechs, 2 located in the hallway there or in the corridor. It takes advantage of the load diversity. Because this is a classroom and a studio area, it's highly unlikely that they're all going to be occupied at the same time or have the same high density load requirements at the same time. We can take advantage of reduced installation costs. We can also take advantage of higher part load efficiencies due to the variable capacity of the compressor and the blower motors. And then again, because they're both located in the hallway, we improve access for service and maintenance and completely eliminate that small unit above the office. In that alternate design, we've got two units totaling 8 tons of nominal capacity. We go to 8 individual zones of comfort control in this, and we go from 14 to 12 pounds of refrigerant at an alternate bid cost of just over $10,000. The real impact here is when you start to look at the benefits in terms of installed cost. And one of the greatest challenges of any project is to either stay at budget or even potentially come in under budget. And so we can see here that based on RS means data from construction cost nationwide, that the cost to install these 4 water source heat pumps is around $27,000. And if you think about all of the hose kits, the ductwork, the electrical connections, breakers, and all those things, it really is it's not hard to see the fact that a 1.25 ton unit, the cost of installation really isn't impacted when you go to a 2.5 ton. But by eliminating 2 of those units, we're able to actually come in again a little bit over the initial design budget, but with the lower installation costs, we end up at a first cost installed at 12% lower than we would based upon the current plans and specifications. We also, because of the variable speed nature of the product and the part load efficiencies, we can go from an average 15.9 cooling EER to a 17.5 IPLV cooling efficiency. So a 10% increase in cooling efficiency, all at the same time that we're able to provide it at 12% lower installed cost in the system. So the importance really here is that Water Furnace is offering not only a product, but we're offering an entire system. So we're providing a very intelligent and a very efficient unit that has the ability to work with a zoning system that is also is highly efficient and is smart in the controls. And so what we end up with is a very intelligent zoning system. And again, I mentioned that the system can be configured as a standalone configuration for a small office or something, or it can be integrated into BACnet. There is a IZ2 BACnet version available as well, utilizing similar components. The only difference is the thermostats are swapped out for actual zone sensors, which again can read temperature and humidity, even temperature, humidity, and CO2. Some of the applications for this product typically are smaller buildings, so smaller office buildings, education, so maybe a small area within a school that you're looking to zone to eliminate units, to increase efficiency and lower install costs. Some small medical office, dental offices, things of that nature. Condominiums, we've seen a kind of a resurgence of multifamily housing and condominiums pop up across the entire United States, even in remote little Fort Wayne, Indiana. Apparently, there is a population that really wants to live downtown. And then finally, in retail spaces as well. So again, in conclusion, I just want to say that I appreciate your time for being with us today. I hope that that Water Furnace will be given the opportunity, if you have the chance, to give it that to us, to show you how we can redefine your next project with our different products, not only including variable speed, but all the other products. So again, Water Furnace is helping to try and redefine how water source heat pumps are viewed in the industry. And with that, I will turn it back over to Jeff for some final comments and let him open it up for questions.
And
Thank you
thanks,
again.
Rich. Again, if you have any particular questions, please type them into the chat area and we'll get to them as they come about. A few thoughts or ideas. Right sizing is so important, especially when it comes to water source heat pumps. Unfortunately, while you do have a variety of sizes, you may not be able to hit your load exactly. And I know as engineers, it's extremely challenging to find out and forecast what that load is going to be, given the changing nature of projects and, construction and how that impacts sizing and whatnot. But one of the benefits of this technology that I certainly want to point out is that you do have the ability to have that diversity for the entire system that you're serving. You have a greater swath that is served by one single unit. So other than savings from, the initial cost of the units, the installation of the units, even the handling of the units to the specific job site, and then once they're on the job site, having that diversity is going to make your job as an engineer a lot easier, because undersizing is certainly a problem, but oversizing can be just as a difficult problem to try and solve once it's in the field. So this eliminates a lot of that risk that you might see. Zoning is very important, but it's extremely flexible with this. So if you do have something that's a very specific zone, let's say a conference room that you don't want to overheat or undercool, you can certainly add an additional unit just for that, but then take benefit of all the surrounding spaces for this variable type. So this gives you a lot of flexibility in that. And the other hidden factor that you see, especially when you're talking like a VRF system, is condensing units, right? With a VRF system, you can share heat around the system, but only within a condensing unit. You can't share it around the whole building. So you have to gerrymander these really weird zones where you've got a condensing unit that has a north exposure and a south exposure in order to be able to share the heat back and forth. Well, it's simple. It's one of the basic rules of a water source heat pump where you don't have that problem because you're putting everything back onto a loop. You can truly share the load throughout the entire building, and that increases efficiency way above what we see from these distributed refrigerant type systems. So do keep that in mind. I think you answered one of my questions, Rich, to start off, is about BAS interface. You said at the last few slides that is certainly available in these systems, correct?
Yes, that is correct. It is only available in BACnet. Unfortunately, LAN seems to be a disappearing communication protocol for many controls companies. And so unfortunately, we don't have the ability to do anything other than OpenN2 or BACnet at this point.
Yeah, and BACnet is typically what we see requested in specifications, so I don't see that as a big concern these days. But about size and configuration, what size do these units come in, and can we get them in vertical and horizontal styles?
Sure. So they're available in sizes ranging from 2 ton all the way up to 15 ton. They're available in vertical configurations and horizontal configurations. The 10 and 15 ton units actually are available in a bottom flow or counterflow configuration too. In the Midwest, we typically see these installed in mechanical wings above classrooms in elementary schools. So a lot of flexibility with the configuration of the unit.
Well, and we see a lot of these, especially on schools that are done in mechanical hallways, mechanical closets that are between rooms themselves. So you'll have a closet that might have 5 to 10 units as you walk down the line. And those are not just the units themselves, the compressors, the complications, the reversing valves of each one of those units that need to be maintained and looked at, filters and whatnot. But then all the appurtenances that go with them, the hose kits, the strainers, the balancing valves that need to be flushed or maintained over time. So rather than having that little wing of 10 to 15, you might be able to do it with 1 or 2 units, depending on the zoning, and then reduce complication in the entire system. The old keep it simple, stupid principle. So
correct.
Well, we don't have any particular questions at this time, but again, I want to thank everyone for joining us today. If you have a last slide, Rich, you can flip to. We do have a presentation coming up next week. So please join us for that on airflow monitoring. And if anybody wants to stay online and unmute themselves, we can stop the recording. But I do appreciate your time today, and hopefully you can join us next week. Thanks again. Thanks, Rich. Thanks,
Thank
Dean.
you.
Thank you, guys. Absolutely.